All movement of the human body is surprisingly complicated and difficult to analyze. But in order to understand motion, analysis is what you need. That's what these little markers are all about. They can be tracked on a computer to reveal the underlying motion of my skeleton. It's the only way you can follow something even as seemingly simple as the movement of a limb. Dozens of joints and bones moving in harmony. Even a clapping stick man is characteristically human. The most ambitious use we made of motion capture was to analyze how babies crawl. The top speed of a crawling baby is about 2 kilometers an hour, and the average baby crawls perhaps 200 meters a day. If you look carefully, the motion capture can identify 7 different types of crawling. To film motion capture, we assembled 10 babies and their mums, 20 crew, some of whom were specially trained in sticking infrared sensitive reflectors on babies' bottoms, a nervous director, 8 infrared cameras, and a team of French experts who knew how to use them. The only hitch was persuading the stars of the show to perform.
Oh, good girl. Come on, Molly. Come on.
The end result is an amazingly accurate crawling skeleton, moving exactly like the real babies.
You are a real star.
A family of chimpanzees. They're pretty good at using sticks to pick up ants and termites for food. And they can turn stones or logs into tools to make life easier. But they have one problem, the shape of their hands. Look at the thumb, it's very short. The human thumb is much longer. This longer thumb is an enormous benefit. We can make a precise finger pinch between thumb and forefinger. It's called the opposable thumb. And it's one of our advantages over the chimpanzee. There are 206 bones in the human skeleton. Together, they give shape to our bodies. Some of them protect our more fragile organs, like the heart and lungs, and the brain. The brain is surrounded and protected by the skull. There are sockets for the eyes and nose. Teeth are embedded in the jawbone. The skull is not just a single bone. It's made of several bones joined together. This newborn baby's head looks an odd pointed shape, and under the skin you can see why. His skull is still pliable. This flexibility let him squeeze through the birth canal. The bones that make up his skull haven't yet fused together, and there are still holes between the bony plates. the backbone or spine. From the base, right up to the neck, it's made up of vertebrae. The shoulder is made up of two bones. There's the shoulder blade, or scapula, and the collarbone, or clavicle. The lungs and heart are protected by the rib cage. In front, the ribs connect to the breastbone, or sternum. The shoulder blade is joined to the upper arm. The bone is called the humerus. The upper and lower arm joint at the elbow. There are two bones in the lower arm, the ulna and the radius. The hand and wrist are an intricate mesh of tightly packed bones. But these X-rays going backwards over 20 years show a remarkable thing. The hands of children are not all bone. There, for instance, no knuckles. And there, look at the gaps in the wrist. Instead of bone, there is cartilage, soft tissue that X-ray doesn't show. As a child grows, and particularly during the growth spurt of puberty, the cartilage turns into bone, the joints get bigger, and the limbs get longer. The hip bones are also called the pelvic girdle, and in teenage girls these bones change and grow in a special way. They spread outwards and become flatter. But more important still, the space between the bones becomes wider. Wide enough to allow, eventually, the birth of a baby. Down from the pelvis and the hip, the upper leg bone is called the femur. And this connects in turn to the knee joint. The knee joint is a complex array of muscles and tendons. Watch it move. The two bones don't actually touch. It's the soft tissue between the bones which allows the joint to move in a smooth and precise way. But sometimes the system goes wrong. This heat-sensitive camera can detect differences in the heat emerging from the various parts of the body. To the naked eye, there's not much difference between her two knees. But to the camera, there definitely is. One knee has a cool blue and green color, but the other knee has a hot spot in red. This is how the joint works from the inside. The ends of the bones are protected by a membrane of cartilage. They never actually touch each other. Now, take away the bones for a moment, and we're left with that cup-shaped membrane. Inside, a small hole has worn in the membrane. The two bones can now touch each other and grind together, damaging the surfaces. This is called osteoarthritis. It's very painful and affects many elderly people. Below the knee, in the lower leg, there are two parallel bones called the tibia and fibula. And they connect to the ankle and foot. Look at the bones of the hand and the foot side by side. What similarities can you see? And what differences?